I'm going to look at dividing fractions here, and I'm going to try to teach it a few different ways. Hopefully it helps you conceptualize kind of why the division operation works the way it does. So I'm trying to visualize this problem right here. So I drew 3 black lines and then 2/3 of another black line. And I'm looking at dividing these black lines into 2/3. So I drew this red line to be about the same size as this one right here, which is 2/3. So if I was to um, divide up all these black lines into the red lines here, you can see there would be one group of 2/3, clearly 2 groups of 2/3, 3 groups of 2/3, and then a 4th group of 2/3 right here. And then what do we have left over? 1/3, another third, and then another third. So 3/3 left over. So really we'd fit one more of these whole things on here. We'd get an answer a little bit higher than 5. And the way that we've been showing this in class is to do make this, first of all, an improper fraction. So we'd make it 11/3. Divide it by 2/3. Keep the first fraction the same. Change division to multiplication and take the reciprocal, right, of that second fraction. So we flip that fraction around almost. Numerator and denominator switch places. The 3's cross reduce here. And if you look at, we get 11/2, which is the same thing as 5.5, right? Because 2 goes into 11 5 whole times with 1 left over. So that would be 5.5. And we said at the very beginning here, we had 1, 2, 3, 4, 5 lines, and we had that little piece here left over. And you might have said, well, shouldn't the answer be 5 1/3? And remember, you're not dividing by a whole number here. You really have you divided by 2/3, so you have half of 2/3 left over, which is 1/3, and that's why the answer came to 5.5. Another way of thinking about this, you could just, because these denominators are the same, divide straight across. 11 divided by 2 would be in your numerator here. So that's, sorry, that might look like a 1. That's supposed to be a fraction bar. And it's over 1, so that's the same thing as saying anything over 1 is itself. So that's the same thing as saying this, which is what we also got for our answer down here, 5.5. And then if I just look at this from an estimation perspective, this number is about 4. So I'm just rounding to whole numbers. This is about 1. 4 divided by 1 would be 4. So we got an answer sort of close to 4, didn't we? I mean, we didn't get like, I don't know, 100 or something ridiculous like that. This problem down here, in terms of, we could do the same process. We could keep the first fraction the same. Maybe I'll do that first. 1/5, keep that first fraction the same. Multiply, and then take the reciprocal, which would be 7/5 here. And if we just multiply straight across now, we'll get 7/25. But picture this in the real world. I'm going to do the best I can. You might be familiar with area of a rectangle. You do length times width or base times height. I'll write length times width. They're the same formula. Imagine that we knew the area of a rectangle. Let's say the area of a rectangle was, I don't know, 8 feet squared. I'm not going to put the feet squared just because it takes me too long to write. But we'll say the length is 4, and we don't know the width. Now, everybody would want to say the width is 2, and you'd be correct to say that. But sometimes the problems aren't, this easy to do in your head. So let's say the area of a rectangle was, I don't know, 1/5 of a mile. All right, and we know that the area is equal to the length times the width. So if the length was 5/7, well, how would I get the width, right? That one's not as easy to do in your head, but if we look back at this problem, all I needed to do was divide by 4 on both sides of the problem here, and if I divided by 4, the width would equal 2, right? 8 divided by 4 is 2. If I just do the same thing here, if I just do 1/5 divided by 5/7, I'll get the width, and that's kind of the usefulness of being able to divide fractions on problems like that. So you do divide fractions by fractions in the real world. So 1/5 divided by 5/7, that's kind of a real world application for it.